Alrighty, good morning, folks. It's your boy Mr. Walker here in the cut on the internet, and we're getting these notes in here. We're talking about similar figures, baby. So let's get into this. Alright, first thing you want to note is the changes with our symbols. If you remember back over here, last part of our unit, we dealt with congruent. So this symbol here means that we are having two parts or two shapes that are congruent. We're dealing with this symbol now. This symbol is going to be if two things are similar. Okay? Folks, if you hear anything, that's my cat in the background. Say hi, cat. Meow. Meow. Kiss, kiss, kiss. Okay, so what do similar figures have? And first definition, cha. And second. So, similar figures have corresponding angles, which are congruent, and the corresponding side lengths are going to form ratios. If you remember ratios, those are fractions, okay? So, main thing to note, these are going to have the same shape, but they are going to be different sizes, okay? So, you might note a couple things around you that are similar. If y'all working with pens and somebody else is working with a pen, they might both write in ink, but they aren't exactly the same. They may not have the same amount of ink, the same color ink, whatever. They are both pens, though, so that means that they're going to be similar. All right, what should we do? Let's look at a quick example here. All right, we got two triangles here. We got a little one on the left, a big one on the right. All right, so when we were dealing with congruent in our triangles, we noted that the parts that matched up in their names are the parts that correspond with each. So, when we're looking at these names, we got triangle ABC and we got FGH. So, ABC and this symbol here, remember, this is similar to. So, I'm telling you triangle ABC is similar to FGH. So, I went and made these triangles face the same way so we can really easily see which things correspond. Let's take a look at them. Remember, A and F, they're both in the beginning, so that means their angles correspond with each other. B and G, they're both in the middle, and they are also corresponding. And then finally, we got C and H. They're both over there on the right, and they correspond to each other. So, with our first definitions, we realize that these angles are congruent. So, when we go through and note these, we want to make sure that we are, again, paying attention to these things. Oops, sorry. Pulled up the next thing, but I didn't want to do that. All right. It's going to be important for you to go through and start paying attention to these marks if I don't give you any numbers. These marks indicate to you which angles are congruent. Okay? So, A and F, they both match up. A and F, they both have that same one little ring on it. V and G, they both have that same two rings on it. So that means that they're the same. C and H, they both got three, so they're both going to be the same. All right, so that's our first part of our definition for similar figures. What about our second one? We got corresponding side lengths which form equal ratios. So below this, we got one, two, three fractions that we're going to make. Each of these fractions are going to be equal at the end of it. So let's go through, let's check. We set up our fractions with our sides that match up. So we got AB and FG. Those two match up. So they're going to be in a ratio together. Then we got BC and GH. That's these orange right there. And then finally we got our purple side, which is CA and HF. These sides are all going to make a set of equal fractions. What do I mean by equal fractions, equal ratios? Let's go through, let's talk about it. All right. If I look at these two, what I'll have, let's give a couple numbers for the small triangle. 1, 2, and 3. Oop, that 3's yuck. Let's go fix that. Hit the eraser. Get the pen. And is this better? 10 out of 10. It's a better one. All right, so we obviously got a small triangle to the left, a bigger one on the right. So if these sides correspond, you're going to notice a very easy ratio that's going to form up. All right, let's talk about our blue sides here. Imagine AB is 1 and HG, let's call that, let's say 5. So let's go through, let's write on there. 5 right there, boom. So we got 1 and 5. Let's say this orange side over here, let's call that 10. And our purple side, let's call that 15. Ooh, 5 is rough on that one. Boom. All right, so if we look at these sides, and I wanted to go through and change up what we have down here with the side lengths that match up, let's go through and put those numbers in. All right, AB is 1. Well, let's actually make sure we can draw the 1. Got the 1 there? Yeah, okay. So we got 1 here. We got the side that matches up with it on our bigger triangle is 5. So we got 1/5. Then we got 2 and 10. So 2 and 10 match up. Boom. And then we got 3 and 15. Now, all three of these ratios are, in fact, equal to each other. If you went and looked at all three of them, you can reduce them all by the same thing. So the first one, we don't need to reduce anything down. But the second one, we can reduce 2 over 10 down to 1/5 again. And then 3 over 15 also to 1/5. So these all have the same ratio, 1/5 or 1 over 5. So when we're dealing with these, you're going to notice that math is going to pop up as we deal with this. All right. Now, as a quick aside before we deal with an example, if you're dealing with circles, I want you to make sure that you understand that all circles are going to be similar. We're not going to deal with any too much, but it's just important for you to recognize that, remember that, have that tucked away in the back of your head, okay? So, let's get some examples, baby. Let's go. All right. How do we find a missing side? So, at the top of this fraction, I want you to put the words missing side, or in the parentheses, variable. So, our missing side we're going to have as an x. Underneath it, we're going to have the length of its corresponding side. So, whatever our missing side is, to our side that matches up with it on the other triangle, circle, square, shape, anything. The things that match up with it. Now on the other side, we're going to pick a number that we do know from our first figure, the same figure that matches up over here. And we're going to match it up with its corresponding side. So let's go through. Let's get some mathing over here, okay? I'm going to pull up our, yeah, I can do it right here. Cool. All right, so we got 2 trapezoids. They're both similar here. Things that you need to know are what things correspond. So here's 9 over 4 over here. Not 9 over 4, 9.4. Sorry about that. It's going to match up with our missing side. And we do have 2 other sides here that are marked. We want to use the side that matches up. So our longer side on this trapezoid matches up with the longer side over here, which is 40. So what we are going to do is we are going to set up that fraction over here. So we got x, and down here we're going to put the corresponding length to it. So the corresponding length to it is 9.4. And that's equal to, we're going to use 2 sides that we have. So on the top of this fraction, we're going to use another length from that shape with our missing side here. So we are going to use 40. And that's going to match up with 24. All right, a little rough here, but we got this. I believe in this. So let's lower this down. We got cross multiplying action. So we're going to multiply the numerator of each fraction times the denominator of the other fraction. So on one hand, we got 24. And it is, oh, nope, I forgot something. Sorry about that, folks. 24x. So that should be what we got there. 24x. My badness. Boom, boom. All right, now we got 40 times 9.4. I wouldn't feel any type of way if you use a calculator. So make sure that you got your handy dandy calculator, baby. So there we go. So let's clear out some of this old math. We got 40 times 9.4. All right, 40 times 9.4 gives us this big one. That's 376. So let's go through. Let's write that on there. Boom, bam, pop. All right. Oop, need that pen. There it is. 376. All right. So we got a number next to our x. We got to go through and get it away. So we got to go through and divide it, baby. There we go. Boom, boom, bam, and pop. There we go. So we do the division on this side. We're left with just x. Let's go through. Let's do that division. So bong. So I got 376. I'm gonna divide from it that 24. So that 24 is gonna give us this right here. I'm gonna probably put this as 15.7, just so I can round that and make that a little easier to deal with. So 15.7 is my answer. So if I wanted to check this though, we're going to go through and run the math in our calculator to see if this works. All right. First thing that you want to go through to do, these are two fractions. So one of our fractions we're going to check is 15.7, and we're going to divide from it 9.4. Now, I will warn you a little ahead of time, because we rounded for this top one, it's going to get close to the number that we're looking at with the other one. So don't feel any type of way if you do round. If you do round, it does change some of the numbers up. All right, let's check to see if these two are equal, okay? And pulling up the calculator. All right, so we got 15.6667 or 15.7. And we are dividing from it our, where is that, 9.4? 9.4. All right. So, dividing that, this is about 1.67. Now, let's check our other one. We got, our other fraction is 40 divided by 24. So, this is around the same decimal. This decimal, because we rounded earlier, is a little off, but since these are pretty close to each other, I think that is A-OK. There we go. So, let's go through. Let's hit up some more examples, my dudes. All right. All right. So, we got two sets of triangles that we got to go through and figure out. So, first thing we got to do is set up some fractions. All right. So, we got our missing side. We're going to put underneath it the thing that matches up. Then we're going to take from the same shape, R10. And we are going to set that up with the side that matches up with it, which is 15. So we got X and 21 here. We got 10 and 15. We set up our fractions. We're going to go through and hit that same math that we just mathed out. So X times 15 gives you 15X. 10 times 21 gives you 210. All right. So if that's the case, our next thing that we're going to do is divide that, and we're going to get 14. All right. Another thing that you want to go through and just see if you're ever worried about, does my answer make sense? Look at your two triangles or your two shapes that you're dealing with. If you're looking for a side that's on the smaller shape, just make sure that the X that you found is, in fact, smaller than the one that we have here. So since we got 14 over here for DF, that is smaller than 21, just like how 10 is smaller than 15. This does make sense in terms of the actual size of these. The next thing that you want to do to check them is just check your math. So pull out your calculator, boom. So we want to make sure that both of these fractions that we made will, in fact, give us the same thing. So if I got 10 divided by 15, we got 0.6667. If we do the same thing with the other side, so the other side, X was 14. So we got 14, and we are dividing from that 21. So 14 divided by 21. Same decimal, check a Rooney. We're in there like swimwear. Baby, let's get out of here. Let's do the next thing. All right. Next. So, I believe this top part, this was from the We Do It on your paper. This bottom one, this is from the I Do It. I'm going to give you the beginning to solve this, but you're going to have to go through and do the rest on your own, okay? So, same type of deal as this. We just got to go through and set up our proportion, our fractions that are equal. So, we got our x, and we got 75 on one triangle. On the other one that's smaller, things that you want to notice, these are turned around. So I don't want you to immediately think 75 matches up with 30. Look at the way the shape is. The longer slanted side is facing to the left on this one. This one's facing to the right. These are clearly flip-flopped around. But other than that, you can also make sure that the sides that you're looking to match up with their names. So AC is over here. That should match up with DF, which is 18. And 75 here, which is CB or BC, either or, matches up with the side that says EF or FE, either way. So, I'll give you the first part, but you're going to have to be able to go through and try this on your own, okay? Check your answers over on Google Classroom. I'll let you handle that. Handle your business, folks. All right. Next one we're going to do. I'm going to do the other part of the We Do It. You're going to do the same thing for the I Do It, okay? So, this time I'm telling you to find out what is the scale factor. The scale factor is that decimal or fraction that we use to see if these fractions are all going to be equal. So, let's go through. Let's look at our two triangles. Let's be able to set up some information. All right. We want to make sure that we set up two fractions up. We can set up three, but if you notice these two have the same number, you can kind of assume the same thing's going to happen here. These are similar after all. So we're going to go through and set up our fractions. So our two fractions are going to be 4 over 6 using our bottom two, and 6 over 9 using our two sides. So we want to go through and look at our two fractions. We're going to go and reduce them. 4 and 6 can be divided by 2, and 6 and 9 can be divided by 3, which gives us a nice 2/3. 2/3 is our scale factor. This is also can be written as 2 of 3. So you can write it either or. I'll take either because these are both the same exact thing. All right, folks. Now remember, you're going to have to follow this logic here. So set up your fractions with your sides that you can clearly tell are going to match up. And then this is going in your book, baby. Now, last thing I want to go through and do is give you guys a little bit of assistance with our last two questions, okay? So let's see, where's the one? All right, so one of the things that we got here, we got a real life situation with Max and our tree friend. Our other one that we got is with a map, and we're going to be using the scale and its ratio so we can find what it is in real life. I'm going to give you the beginning parts of this. So, for our first example on the bottom, it's important for you to recognize which parts match up. So, it tells you Max is 6 feet. So, obviously, my man's here in the sweater is 6 feet. His shadow is 8 feet. So, clearly, this black line is his shadow. Now, the tree that he's standing next to has a shadow of 24 feet. And we don't know how big this thing is. So, set your fraction up. Here's half of it. You can clearly figure out what the next one is. So, find out what the next one is. Alright. The next one, even though I give you 2 over 6 like this, or 2 and 6, remember, a ratio is the same thing as a fraction. So this can be written as 2 over 6. Now remember, We are trying to find something in our proportion to set up. So it says Dallas and St. Louis are 210.3 centimeters apart. And they tell you that this map scale that we are using is 2 centimeters to 6 miles. So for every 2 of these centimeters, there is 6 real miles. So they give us your centimeters to work out, but you got to find out the real length in miles. Here's your fraction. Set it up and knock it down, folks. All right, when you're finished with this, we got some more practice so we can get this down. So I'll catch y'all on the flippity flip. See you later, alligator. After a while, crocodile. See you later, toodaloo. Boom.